Tired of energy sources that are slowly killing the environment? Worried about what will happen when our limited supply of fossil fuels runs out? Afraid that toxic waste will mutate you into a superhuman crime fighter? Wait, actually that might not necessarily be a bad thing. Anyway, the planet is dying and we need to do something about it. How can we do that, you ask? Look no further than nuclear fusion. What is nuclear fusion? To put it simply, nuclear fusion is the process of fusing two hydrogen molecules to create a molecule of helium, an excess neutron, and excess energy. Nuclear fusion is the main energy source of the Sun, requiring pressure levels that are unachievable on Earth. In order to achieve fusion on Earth, particles must be heated to temperatures reaching hundreds of millions of degrees. Why should we care?
If perfected, nuclear fusion would provide an almost perfect alternative to current methods of energy production. Fusion energy doesn't involve the drawbacks of environment pollution like fossil fuels, doesn't produce toxic waste like fission energy, and produces significantly more energy than current fossil fuel alternatives, such as solar and wind energy. The only realistic drawback of fusion is that, at least in the near future, it will be an expensive method of energy production. The challenge of fusion on Earth. The conditions on the Sun are perfect for fusion reactions to take place. However, the extreme temperature and pressure on the Sun is difficult to replicate here on Earth. To counteract this issue, fusion reactions on Earth must take place at temperatures vastly greater than those on the Sun. This is difficult to accomplish because the materials we currently have available to build fusion reactors cannot sustain such conditions. Current solutions. There are some materials that we can build reactors out of. Our most likely candidate is beryllium. However, obtaining enough beryllium to build a reactor with is currently a difficult and expensive task. Beryllium rarely occurs naturally, so it must be synthetically produced. Until we create a means of producing large amounts of beryllium, large-scale fusion reactors aren't possible. Fusion has the potential to be the energy panacea our race needs, but first, we must overcome the logistical hurdles that block our path. We have a lot of challenges ahead of us, but once they are out of the way, fusion energy can easily meet our energy needs here on Earth and on our ventures in the stars. This task will go to the current engineers of the world and those to come in the next several decades.